Hello everyone. How you doing?
Great.
Good. Good to hear. So at this point in the QA training, you've been through the policies, you've been through the basics. So now you know about bug severities, the types of bugs. At this point, I'm going to cover bug finding, which is probably the most important part of the QA process, where you actually find the bugs and record them in our database software. All right. Now, one important distinction that I have to make from the very beginning before we go too far into it is playing versus testing. Now, a lot of people you know might tell you you have the greatest job in the world playing a game all day. And you can correct them by saying you don't play a game. You test the game. You test the game for quality, for form factor, and for our own standards. You don't play the game at all. A couple of points here. Playing the game is often used in reference, but the act of going from start to finish is indeed playing. However, in testing, it's a more methodical progression from based on constructive destruction, is a form of saying it. So basically, we take the game and we break it, we destroy it, we break it down, make developers cry, and then bring it back up, telling them here's what you need to fix. And that's our purpose in QA. We need to break the game, test it, and tell them what's wrong with it. And of course, the ultimate the end result is we report defects in the product in the QA database, which is us putting in bugs, as we call them, to make sure that they get them as formal reports of what's wrong with the game. There we go. All right, some standard methodologies we have in QA. One is verification. These are designed to formally confirm if something works the way it's supposed to in the game. This type of testing is not trying to break the game as much as make sure that the game meets the design standards and specifications set by corporate and design requirements. So verification is very much checking that the game is appearing and functioning as it's designed to do. Whereas failure testing, these are designed to expose failures by using methods that we know typically cause failures in software. And this is all based on past experience, past projects. So the leadership on a QA project will develop these failure tests to check if the game fails or passes based on these past experiences with other projects. Again. All right, here we go. Some more in-depth into methodology. Scripted. Some types of scripted testing are test cases, scenarios, scripts, and checklists. With scripted testing, there's no room for being creative, no room for going your own way. It's all based on parameters, testing the features and functionality of the game to make sure it works as it's supposed to work. So no going off the beaten path in scripted testing. You just follow it as a design, as the scripted testing design. Some examples are verifying third-party guidelines such as Nintendo, Microsoft, and Sony's standards. They all have their own different standards. Some are somewhat lax, some are not. So we have checklists that help us check if these standards are being met in the game or not. And another example, testing combinations of different weapons between two players. There could be 300 weapons in the game, and if testers are left to test those creatively on their own, not that they couldn't test them all, but the more sure way to check this is by scripted testing. Basically, a checklist of every weapon combination in the game. It could be 1,000, 2,000, pretty normal number. But it ensures that we check every possible scenario and variation to make sure it functions as it's supposed to. Here we go. So we have scripted, and then we have the opposite, not the opposite, but the inverse, which is unscripted testing. Unscripted is sort of here's QA's bread and butter. We have different QA studios throughout the EA corporation. Obviously, we have EAC. Up in Canada, we have testing in Romania, etc. And each studio tends to have their own way of testing the games, based on their own history and their own culture at that particular branch of EA. Here at EARS, we're known for our creative testing. We, for the most part, we do scripted testing, of course. Every division should, but we definitely focus more on the unscripted, which is the game testing, ad hoc, being creative, exploring the game, play testing, just taking the game and essentially going nuts with it is one way we like to phrase it. This is very much based on experience, knowledge, and initiative. which means the tester is given the game, given some sort of guideline and told, have at it. You know, it's up to you to, based on your own experience, your own knowledge, your own experience with the software. You know, it could be this software, it could be other software in the past, or even if you haven't tested before. It's taking what you know and going into the game and being creative with it and trying to break it and find as many bugs as possible using that experience. Some things to check: or is everything clear? Does it make sense? Is it too hard or too easy? And this is where being creative helps, because we are able to go in and check these things that the scripted testing might not necessarily check for, because it's subjective. Some people might think it's too easy, some might think it's too hard. At that point, you can go in and provide your feedback and put in a bug saying, I believe it's too hard, here's why, based on very specific examples in the game. And this is your chance really to be, like I said before, go nuts with it. Some strategies. Scripted verification is one, as I've covered before, one major aspect of testing. We do scripted verification on almost every project here, just to ensure that we check all the checklists and standards and guidelines that are preset for every project from EA. It's very much scripted testing is very much a pass-fail system, meaning you are given a scripted verification, and an example would be audio levels can be adjusted between 1 and 10. And then the expected result of that is that they would adjust between 1 and 10. And that either passes or fails. No subjectivity to it, no being creative with it. You either pass it or fail it based on what happens in the game at that point in the project. This type of testing would verify design, content, technical standards, legal, branding, guidelines, like I mentioned before. These are our ways of checking the usual stuff in the game. This involves having a keen understanding of the software and product in order to ensure that you accurately assess the predefined test, meaning that there should be some experience with the software. If you go in blind, not quite knowing the game, it might be difficult. And this type of information is typically provided to you by your QA leadership. Whoever your lead is on the project, they'll tell you, here's how to get to this point in the game, if you don't already know. And at that point, you would take the scripted verification and check it in the game. An example would be, like I mentioned before, checking the volume level to make sure it functions as designed. And we usually use these for standards, for third-party guidelines, and pretty heavily in PC and legal checklists. PC is known for having its own unique problems, and because we are very familiar with PC testing, Sims, we can definitely know what to check with any PC products that might come our way. Unscripted. So scripted is very much, like I mentioned before, a pass-fail system, very straightforward, very structured. Unscripted, our bread and butter again, is a very subjective approach. It helps us verify that the game performs to expectations. Now that's very broad, obviously. And that's kind of the point of ad hoc creative testing, or unscripted verification, is to ensure that the game functions as expected throughout the entire game. Well, for this, it helps to have a strong customer focus and a good understanding of the market expectations and knowledge of competitor software. So having knowledge and background in games helps quite a bit in knowing how other games work. That could be past EA games or past other games from other companies. An example would be a playthrough of a level or a section of the game. This could be focusing on the options in the game, meaning you spend all day in the options. Might yield a lot of bugs, might yield very few. But the point is to ensure that any area of the game is tested as thoroughly as possible using this unscripted verification process. It's not so much a destructive process, it's used to uncover serious software issues that are missed during scripted testing. So while scripted testing is very important, it's not infallible, and that's where we use the unscripted subjective testing to make sure we cover every aspect of the game. So testing strategies and areas of the game to focus on as you go along during the training week. Regression testing. Regression testing involves running previously created tests or bugs in the game to ensure that they haven't broken anything new. So you could have a bug that was put in on a certain build, say build 5. On build 7, they claim it was fixed. So you check this bug to make sure it's fixed, and you also check that the fix didn't affect anything else in the game. Because that can happen. They'll fix something and break firewall. It's just the way QA works. So this helps to ensure that the software is not It's progressing thoroughly. It's not being broken more than it's being tested. Boundary testing. This is checking the limits prescribed by programming. This often involves checking scores, stats in the game, counters, anywhere where there's a possible limit, there's a quantitative limit or a numerical limit or what have you, is a good way to check boundary testing to make sure that the limit can be reached, or if there is a limit, it doesn't break, it doesn't cause the game to crash or not work. So that's one good way to check that. Slice testing. This is a very focused type of testing where you go room by room, level by level, or area by area. And the slice testing involves pretty much taking the game, breaking it down into small chunks, essentially, small palatable chunks that you focus on. So today it could be section 1.1 of the level, tomorrow it could be section 1.2, section 1.3, and so on. And it helps to break down the game into manageable pieces so that you're not too overwhelmed. Again, this type of testing is usually assigned by QA leadership, but on certain projects, the testers are experienced enough or trusted enough to have to do that on their own. The leadership might assign you to just play the game creatively. And at that point, it would be very wise to consider slice testing as a way of breaking down the game into manageable pieces. Soak testing. This type of testing involves leaving the game sitting on one screen or area of the game for an extended period of time, usually overnight, as that's when the software can be left alone and no one has to use it. It's used to ensure the stability of the game is functioning as it should, and no defects are caused. Examples would be leaving the game sitting at the main menu. I know many people might start the game, and they have something in the oven or something in the microwave, so they let it sit for a good 30, 40 minutes on the main screen. And the purpose of soak testing is that game doesn't crash or break down sitting on the main screen the whole way through. Category testing. This involves zeroing in on a particular type of defect in the game, which is different from slice testing earlier, where slice testing involves certain areas of the game. This is certain categories, such as graphics, AI, standards. In this type of testing, tester experience plays a big role, because it really depends on your background. So some people, if you're given free roam with the game, some people are more visual. They notice graphics more, they notice the visuals of the game. So if you're a visual person, you might want to focus on the graphics of the game. Whereas if you're more detail-oriented, you might want to focus on standards, such as say, for example, a Wii game. Nintendo is notoriously strict in their guidelines. They will fail us very easily, and they don't play around. So if you're very detail-oriented, you could focus on standards, taking the Nintendo standards documents we have and running through the game and ensuring that the standards are met throughout the game. Functionality testing. This involves checking the game versus the manual, the documents, suites, or guidelines provided by development, which means you're testing the game to make sure it works as it should be working, versus the documentation provided. Now, this can vary depending on the project. Some developers are good about keeping the documents up to date, some are not as much. But we pretty much, at the beginning of a project, we pretty much test against these documents. And if there's any variation at all, we generally write bugs based on those variations. Meaning the audio in the game does not match what is designed in the documents. Would be an example of the result of full functionality testing. Smoke testing. This type of testing pretty much involves loading up the build for the game, and making sure that it works and doesn't crash immediately. This is a part of QA, but not so much the main QA team. This is usually done a few hours before by a tester on the development side, and ensures that the game is running and works as it's supposed to. Works enough for us to test. The term smoke testing comes from actually testing hardware, because testers will plug the hardware into the wall and leave it running for a few days to make sure it doesn't smoke. So literally, smoke testing involves checking the hardware to make sure it doesn't go up in flames or smoke. Performance testing. This type of testing is more expensive in PC games, but does occur on console games as well. Performance testing involves checking the performance of the game, meaning the frame rate, making sure it runs at a smooth 20 to 30 frames per second, which means there's no noticeable lag. Anyone who's a gamer will sometimes notice that given enough going on the screen, enough action on screen, the game can lag. And our job in performance testing is to ensure that the game does not lag too severely, that the game runs smoothly enough and does not affect the player's experience with the software. And it helps optimize the visuals, if they need to be rendered up or down, improved or downgraded, so to speak. And it helps the programming code get refined as well. So it's a refinement process. We go along, we do performance testing the whole way through until the software is ready to release and it's as best as it can. Stress testing. This involves checking that the limits, this is another type of limit testing, boundary testing. It involves checking that the stability of the game is not affected by having too much of anything going on screen. An example would be in multiplayer server testing, when you can have, say, 16 players in the map. Does that affect the gameplay at all? Does it cause lag? Does it cause any severe issues? Checking if too many characters are on screen in a single player game, too many enemies on screen. What happens then? Does it slow down too much? Does it slow down at all? So it's one good way to test the limits of the game, see how much you can take before it craps out. And finally, ad hoc creative testing, which I mentioned earlier, discussed a bit. And this is discovering defects outside the parameters of scripted testing. This is us. It's not so much hit and miss as it is thinking beyond what you can do or cannot do in the game. It's being creative with the game, thinking outside the box, so to speak. This means breaking the rules. On the following pages, I'll show some examples of ad hoc creative testing, as I mentioned, is an important part of our testing here. And you can see what kind of how much you can do with creative testing. Event collision. This involves checking two events at the same time to ensure that they don't cause any issues, meaning which takes precedence, what can happen as a result. And usually this involves checking if the programmer has accounted for any possible conflicts in the software. An example of event collision would be dying as you complete a mission in the game. What happens then? Does the death take precedence, or does the completion take precedence? And if there's any conflict, what can that cause in the software? So that's what event collision can yield. Boundary limit testing, as I mentioned, is how much can the game take, how much can be on screen at one time. Examples here: how many villains are there in the level, how many can be killed, and if it's too much, what happens then? Repetition testing. This is part of QA. Well, not the favorite part of QA, but it must be done. Repetition testing involves checking gameplay or checking any aspect of the game over and over and over again, which is our job here, to make sure that given enough repetition that the game does not break. Examples are entering and exiting menus continuously, failing and retrying a mission over and over and over again. And while it's not the most fun part of QA, it must be done. So repetition testing is definitely one aspect to look at when you're going through creative testing, because that can yield many bugs just based on the load of having to repeat something over and over again. Reverse logic. This is pretty straightforward, self-explanatory. Reverse logic means going against what's expected in the game. An example here is turning your vehicle in a racing game 180 degrees, going the opposite way. What happens then? That's a pretty literal example. Other examples would be thinking against the way the game should work. So you're supposed to progress to the end of the level. What happens if you get there and go all the way back? Is the level still there? Has it disappeared completely? Is it still, are enemies still there? Or challenges, puzzles still there? So reverse logic pretty much involves thinking a bit more creatively, thinking backwards, and then trying to break the game in reverse. Saving and loading. This is a big issue with the game, and also touches on some of the standards issues we have with Sony, Microsoft, Nintendo, and our own internal quality assurance department here, which tests PC games. Some examples would be you begin testing normally, and then you save a game during an explosion and cutscene right before the player dies. And when you test these different examples during saving and loading, what happens then? So it's a type of event collision when you save and load during features in the game, or during anything that's going on in the game, any action in the game. You potentially cause issues by doing that. All right, so today in bug finding we covered planning versus testing, standard methodologies, strategies, and creative testing. Any questions, any concerns? Let me know.
You're live.
Okay. Hi everyone. So today I'm going to discuss the Sonic Chronicles BioWare project that we worked on here at Ears QA. Now, as you're all aware, and this is the post-mortem. Now, as you're all aware, the BioWare project came in somewhat late in their schedule. They asked us basically, we need help on QA because Sega's not performing to our expectations. And that's where we came in. So Bioware came to us asking, what can we do to help the quality of this game improve, to improve on the QA aspects of it. So they came to us asking basically for support for what's going to be the first named franchise for Bioware using the Sonic license, which is a first for us. And in relation to this, we own Bioware now. So the project started off as a Sega Bioware only. Once we purchased Bioware, it became EARS as well, or EA. So that's where we came in. The parties involved: Bioware QA, Mitchell Fugino, point of contact, very great guy. EARS QA, Keith Adole, the lead on the project, and Sega QA. Now Sega has not been involved as far as communication with us. It's been all Sega and Bioware, so all communication between them has been non-existent to us. But these are the three main QA parties involved in the project. The key dates for EARS QA. 519 pre-submission went well, smoothly. The QA beta of 6.6 has been pushed up slightly, so we're building up towards it. 620 QA final looks to happen. And 623 submission to NOA is also looking to be on track. So we're on track so far. Accomplishments. What went well? Let's take a look. All right, bugs found by EARS QA between 317 and 617. As demonstrated here, 1,197 issues. Out of those 1,197, there was 191 A bugs, 284 B, 689 C, and 29 B bugs. B being the standards issues covered by our compliance team down on the first floor here in 209, which averages out to 239 bugs per tester. That was out of a team of 5 testers, which is a very good number for such a small team. So we definitely provided the support they needed to cover the later areas of the game that they felt were not being covered well enough by Sega QA. Chart here on the left, just a little visual proof. The big bars in, looking good. Closed by Bioware. So we submitted our bugs, they have to likewise go in and close them. Out of 1197, they closed 1,028 issues, which means slightly over 100 were left open, which is about average for a project of this size and this scope. Out of those 1,028, they fixed 814, a very good number. 185 invalid covering reasons such as duplicates, issues that are not valid, issues that don't apply, or tester bugs that they felt were not necessary. That's what invalid covers. And of course, non-shippable 29, again a very good number, which means they didn't pass over too many issues. Only the critical ones only the very minor ones, forgive me, were KS, as they say. Key learnings from the accomplishments. Bioware has a very responsive development team. The responses in their bugs are very detailed, very accurate, so we were not left wondering or asking, what does that mean? What do we do about that? So they were very responsive, and we're quick to resolve bugs. The issues we put in were fixed, usually turn around in about 3 builds. So they did very well with turning these issues around and sending them back to us to verify if they were fixed. Reasonable requests. Some development teams, as you guys might be aware, are very demanding in the way they speak to us, what they ask of us. It's a very demanding attitude and tone. Not this team. They were very reasonable, very understanding of our limitations in QA, especially at the beginning. There was a hardware issue, which we'll cover in a minute. But they were very understanding. They were not demanding, they were not pressuring. They understood what QA is about and what we need to do to accomplish our task, and likewise we accomplished the task. They were very pleasant to work with. Areas of improvement, what we learned and how we can improve for the next project. Hardware. As I mentioned before, there was a hardware issue with our internal team here at EARS. For 3 weeks, we had there was a lack of correct DS cards. So the cards we inserted to the DS hardware, there was a lack of those. We had about 3 out of 5, which means we had 5 testers, and only 3 of them could really test. The other 2 were put on a side project for about 3 weeks. So there was a lack of hardware which we need to address for future projects going forward with them. Loss of DS cards during testing, which means we had 5, and we lost 2 during testing, which means we had to wait another week to obtain 2 more to replace those. So there was definitely a hardware issue in regards to the DS cards, and we've addressed that with our QA support. And they looked into buying just all new hardware altogether. Stuff that hasn't been around for 3 or 4 years. Dedicated testing. During the course of this project, we had 5 people, but these 5 people, because they were assigned to other projects, were diverted every now and again to other projects, which resulted in Sonic QA being short a few people, say 3 people for a period of 2 weeks every month or so. And this, as a result of this fluid tester movement, it resulted in lack of QA for a couple of weeks at a time on our project. And that's something else we need to address going forward on your side. Gathering a dedicated team of testers for the project for the duration of whatever it might be it 3 weeks, 3 months. Status updates. EAR's QA definitely lacked in the status updates to BioWare. There were weekly emails sent out, but that, in hindsight, it was definitely not enough. So while EARS needs to send more updates to BioWare, likewise EARS needs to request more updates from them in order to be in the loop. Because while BioWare, say, were the main teams involved in this, we at EARS are the parent company of BioWare, need to be involved as well. So definitely more status updates from us to BioWare, BioWare back to us. EARS BioWare. Database inconsistency. This was a major issue in that BioWare started off using the ExtraView bug database, and we here at EARS use the DevTrack bug database. And it was decided by management to use both databases at the same time. That meant that we at EARS submitted bugs to the DevTrack database and again to the ExtraView, so that we were doubling our work, essentially. This, at the beginning, seemed like a good way to work because we could track our own bugs more accurately using our own software. But as a result, both the testers and management have to double their efforts to track this, to insert bugs or submit bugs, and likewise to track and report the bugs to management. So it was double the work at the cost of our efficiency of testing time. Database ownership. The main database being the ExtraView one was owned by BioWare. As a result, we had no ownership over that database, which meant that we essentially were reliant on BioWare to resolve issues, to close issues, to track the final number of issues, which are all in the ExtraView database. As a result, the management standards were not up to EA quality, in my opinion. So given that, for future projects, we definitely need to address this issue as we should use one database, either ExtraView or DevTrack, preferably DevTrack, to prevent the management standards being out of whack. So we have more visibility, more ownership of the database on our end. Tester consideration. Because BioWare owned this database and essentially decided what gets resolved and what is invalid, they were closing various bugs that we felt were valid as duplicates or invalidations. And again, this is standards differentiation between us and BioWare. And in this case, I felt that if we had ownership of the database, it would have been up to EA standards. And again, EA owns BioWare now, so while they are a very important group, very independent, it's important to retain that standard throughout all divisions of EA. So that's another issue of tester consideration, making sure the testers feel their bugs are being considered accurately and not being closed out without regard. Any questions?